Hey guys, this is 1.5. We've come so far. This is the last this is the last lecture from chapter 1 of the book. We will go on to 2.2 and 2.3 after that and then have the exam. So we've covered a lot, 2.3 and 2.2. So in the future, we're going to graphing on the coordinate plane. So this is the last one before that. We've covered linear equations, we've covered quadratic equations, we've covered factoring. We've covered the quadratic formula, how to find solutions with negatives in the radical using the complex number system, radical equations, inverse, and yeah, it's a lot. We're moving on to inequalities. So I'm just going to talk real quickly about the difference between an inequality and something that is an equation. So equation is equal, inequality is not equal. So it's either something is not equal to something, something is greater than something, something is less than something, something is greater than or equal to something else, something is less than or equal to something else. That's what it means. Okay. Let's look at it. Good. All right. So solving inequalities. I'm going to show a little picture of each of these, but this is 3 ways to represent inequalities. And remember, inequality, the way I'm most familiar with it is the less than to be greater than. The greater than or equal to, or less than or equal to, or less than symbols is what we mean when we're talking about inequality, okay? We are going to write them in interval notation. An interval is probably the newest way you've seen it. So intervals are expressions describing where the shading starts and ends when you graph this on a number line, okay? An open interval uses parentheses to represent less than and greater than, but a closed interval uses brackets to represent less than or equal to and greater than or equal to. How I remember it is that it could be equal to that, so it's a bit more serious, like less than or equal to is a bracket because it includes that number. It could be equal to that number, whereas less than is just parentheses. It does not include that. It's just going to touch it. You might also be familiar with an open circle for this one and a closed circle for this one. Okay, and same with the other direction. So greater than, oh, sorry, that's the greater than one. And that's the less than one. Yeah, so closed interval uses a bracket and open interval uses parentheses. So just get used to when you see less than or equal to, think of a bracket. It should be going the direction that the arrow is going on in the less than symbol. So the bracket for less than will have an arrow coming off of it going in the less than direction. The bracket for greater than will have, or the parentheses for greater than will have an arrow going in the greater than direction. But we'll get further into that later. Okay, so we read it left to right, and it's helpful to see an inequality as a sentence. Left on the number line, so picture just a number line, right? Just like in Desmos, a number line is the x-axis, right? We can graph x is greater than 3, that third one down there. We can graph that on a number line. Sorry, x is greater than 3. What we're saying is that our graph starts at the line 3 and goes forever in the positive infinity direction, okay? It's greater than 3, and so it's a dashed line. If it was greater than or equal to 3, it would be a solid line because it would also include 3. So the dashed line denotes that it is not going to include the number 3. It stops before it includes the number 3. But the full line, the solid line, sorry, shows that it includes the number 3. So those are some examples of what it looks like on the number line. The number line is just the x-axis on when we're talking about the quadrant plane, if that helps you. Good? Okay. These two do not include the number we're talking about. These two include the number we're talking about. Okay? Let's just, A is a number in all of this. B is a different number that is not A. Okay? If I'm talking about x is greater than or equal to a, what does that look like on the graph? I guess I need an a on my graph. So I'll start here. Here's a, okay? X is greater than or equal to a. The equal to means I need a bracket. Greater than means the arrow is going to go in that direction, right? The greater than symbol and the arrow should go in the same direction. And it's a bracket because it has the equal sign below it, okay? So that's that one. That's how we write it as an inequality. That's how we graph the inequality. And then the interval notation follows the graph, okay? So this is a bracket at A and then an arrow in the positive direction forever, or we write it as bracket beginning with A and going to infinity. That is that symbol. That's infinity, that's infinity, that's negative infinity, okay? Negative infinity should always go behind your number. Infinity should always go in front of your number, right? So this is always going to go on the left. This is always going to go on the right. So just look at your graph like a sentence, read it left to right. Where does my sentence start? My sentence starts at A. Does it start with a parentheses or a bracket? It starts with a bracket. And then it goes forever. Forever just means infinity. Okay, so that's our first one. Also, feel free to fast forward if you're comfortable with this information. Next, x is simply greater than a. So here's that same graph of a. Now x is greater than a. It's not greater than or equal to a, but we still have an arrow. We still have a greater than symbol, and a greater than symbol makes me think of an arrow going in the positive direction from A, but there's no equal sign, so it's going to be parentheses, okay? Where did I start? I started at A. How did I start? I started with parentheses, and I went to infinity. So that's how I would write interval notation based on my graph, or that's how I would graph if I saw interval notation, okay? Next one. Need another A. This is x is less than or equal to A, okay? Less than, the arrow's going that way. So from A, I'm going to go in the negative infinity direction. It has an equal sign, so I'm going to put a bracket on it. Good? Bracket, arrow going that way. I begin from left to right with an arrow pointing towards negative infinity. So I start with negative infinity, and I end at A. A had a bracket, so I end with a bracket. That's how I'm deciding this, okay? That's how I'm translating from graph to interval notation or interval notation to graph. The next one is x is simply less than A. So it's similar. Less than should still be going in the direction of that arrow. Less than arrow, arrow going in the negative direction. It's not going to include a bracket because brackets go with the equal sign. It's just going to have the parentheses. So I'm done. Okay. How do I read it? It starts with negative infinity. So I'm going to do parentheses, negative infinity. It stops at A. A has a parenthesis, not a bracket. So I write it as open the parentheses, negative infinity, A, close the parentheses. Good? Okay, here we have compound. So this is going to be A is less than X and X is less than B. So now I need an A and a B. I guess it had to be on that line. I need an A and a B. So A is less than X and X is less than B. I like my variable X to be on the left so that I can follow these arrow signs. So X is less than B. So from B, I'm going to go that way. Okay, and there's parentheses. There's no equal sign, so there's not going to be a bracket. Good. Here, I'm going to read it backwards. X is greater than A. Good. And then I just say this goes forever in this direction, but this goes forever in this direction. And when they meet, they stop each other, right? The arrow going this way is stopped by the B. The arrow going this way is stopped by the A. So what we have is it begins at A and it ends at B. Okay. You're also welcome to rewrite this part as X is greater than a. X is greater than a is less than x. Okay? Where does it begin? It begins at a. Where does it end? It ends at b. They both have parentheses, so that's how I do the interval notation. Here we have a is less than or equal to x. X is less than or equal to b. X is less than or equal to b. So I know it's going to be a bracket. Less than is that direction. Okay? And then again, I can rewrite it. X is greater than or equal to a. Because then I know my arrow needs to go that way. And I'm going to be greater than good. Now I write it in interval notation. Where do I begin? I begin at a with a bracket. Where do I end? I end with b at a bracket. Here we have x is less than b. Less than is that direction. It's a parenthesis because there's no equal sign. X is greater than or equal to a, so it is going to have a bracket, and it's going to go this way until it meets b. So bracket a, b, parentheses. And again, you can say x is less than or equal to a for that one. All right, in our last one, x is less than or equal to b, so that's a bracket. X is greater than a, so that's parentheses. Parentheses a, b, bracket. Okay, so that's how I would graph each of these. This is the part, the interval, or the part of the number line. What part of the number line am I talking about? I'm talking about from a forever. What part of the number line am I talking about? A forever. Excluding a, including a. Here I'm talking about from negative forever to a, including it, from negative forever to a, excluding a, from a to b, from a to b but including a and b, including a but not including b, and then this one would be this one would be excluding a, including b. Good. So that's what they mean by interval notation. It describes the part of the number line where the solution would be found, where the shading starts to where the shading ends. And you can put this into Desmos. You can put this into Desmos. Desmos will give you this. It won't do that. All right, example 1. We are doing, sorry, I'm just gonna move it down here. We're gonna do x is greater than or equal to 4 and less than or equal to 7. Okay, so what does that mean? What would the graph of that look like? This is the inequality of it. We're going to do the graph of it, and then we're going to do the interval notation. I think it's easiest to do the interval notation after I've done the graph. So here's 4, and here's 7. Make sure that 4 is actually before 7 on a number line, okay? Just be sure. So we have x is less than or equal to 7, so that's a bracket. It's a bracket because of the equal sign. And then x is greater than or equal to 4, so that's going to be the graph. And then my interval notation, I just take straight from my graph. What do I start with? I start with a bracket and the number 4. I end with the number 7, and 7 is also within a bracket, so that's my interval notation for that inequality. Good? My next one is, I guess I'm going to go down here. X is greater than 3. Here's 3. X is greater than 3. My arrow is going to be going that way from 3. It doesn't include 3, so it's just parentheses. So there's the graph of it. And then when I read it from left to right, I start with a parenthesis at the number 3, and then I go towards positive infinity. So if I see the arrow going that way, it means positive infinity. Infinity only ever has a parentheses infinity, and negative infinity will never have brackets, because bracket means it includes the number 4, it includes the number 7, it doesn't include 3. So remember, when you're looking at this kind of graph of it, greater than or equal to 3 looks like a solid line, but simply greater than 3 has a dashed line because it wants to denote that it does not include 3. So the parenthesis means it does not include the number we're stopping at. A bracket means it does include the number we're stopping at. The next one we have is -3 is less than x, and x is less than 0. And again, you're welcome to write it like that, and then you can also write it backwards. 0 is greater than x is greater than -3, so that you know that you're looking at x is less than 0 and x is greater than -3, if that helps you. So I need a -3 and I need a 0. X is less than 0 and does not include it, right? So it's parentheses. X is greater than -3 and doesn't include it, so that's another parentheses. And then I just write it like that. Where does it start? It starts at -3 with the parentheses. It ends at 0 with the parentheses. The last one is x is less than or equal to 5. Good. X is less than or equal to 5. Less than is an arrow going in that direction. Equal to is a bracket. Done. Just like this ended with infinity because there was an arrow going forever in that direction, this one starts with infinity, but if it's starting over here, it's a negative infinity. So we start with negative infinity and we go until 5. Okay? Inequality graph interval notation. Example 2 asks us to write as an inequality involving x and then to graph it. So again, I'm going to come down here. First example is 0 to 3. The 0 has a bracket, but the 3 has a parenthesis. So that looks easy to graph. I need a graph with the number 0 and the number 3. My graph is going to start at 0 with a bracket and go until 3 with a parentheses because it doesn't include it. Then I'm just going to remember that if it has an equal sign, it'll have brackets, and if it doesn't have an equal sign, it'll have parentheses. Good? So I start at 0, end at 3. It's going up from 0, so my arrow should look like this, and it should include an equal sign, right? Because it's a bracket. And then from 3, oh, sorry, that doesn't work. Okay, we have 0. We know there's going to be an equal sign because of the bracket. It would work if the x was on this side, but it doesn't. 3, we're not going to have a equal sign because it's a parentheses, right? X is less than 3, right? Because the arrow is going that way from 3. X is less than 3, and x is greater than or equal to 0, or 0 is less than or equal to x. Good. Next one. I feel like I'm going down this way this lesson, right? I already committed to it. Bracket 3, 4. Also a bracket. So I need the numbers 3 and 4. Pretty easy to graph, right? You just graph from 3 to 4. And what are we saying about 3 and 4? We're saying that we are talking about every number that is bigger than 3 and smaller than 4. So x is bigger than 3 and x is smaller than 4. The equal signs are because of the brackets. X is bigger than 3, X is smaller than 4. Just kind of talking it out. So here is parentheses 3, infinity. What does that mean? It means I start at 3 with a parentheses, and it goes forever in this direction. All I know is X is greater than 3. X is greater than 3. Couldn't see that at all, I apologize. This will always have parentheses, never a bracket. And then we have negative infinity to negative 5. Negative 5. It ends at negative 5 with a bracket, and it starts at negative infinity, which is just an arrow in that direction. So we're going to say X is everything less than negative 5. The arrow is going in that direction. Less than negative 5. Oh, sorry, I didn't copy that right. It had a bracket. Doesn't work very well. So less than or equal to negative 5. Okay. All right, I feel like I should maybe go back. Because we've got these, right? The arrow is going in that direction, so X is less than negative 5. Because it's a bracket, it's equal to. So X is less than or equal to negative 5, right? But for these, it's a little bit harder. So I have bracket between 0 and parentheses of 3. So I'm between 0 and 3. X is, so if I just had this one, right? This would be X is greater than or equal to 0, right? So this part is X is greater than or equal to 0. And then this part is going to say X is less than 3. So that's another way to think about it. X is greater than or equal to 0. What is the greater than symbol? The greater than symbol is this. So X is greater than or equal to 0, and X is less than 3. Good. And then to make it match, to make it look real fancy, we put the X in the middle, and so we just flip that one around. X is greater than or equal to 0. 0 is less than or equal to X. X is greater than, sorry, X is less than 3. So maybe that's another way to do it. Here, X is greater than or equal to 3. X is less than or equal to 4. X is greater than or equal to 3. X is less than or equal to 4. And then just make those match up by putting X in the middle. So we can say X is less than or equal to 4, and X is greater than or equal to 3, flip that around. 3 is less than or equal to X, so X is less than or greater than or equal to 3, looks like that. So there's more of the process. I didn't like how briefly I taught that. All right, let's talk about solving inequalities. Inequalities are solved using the same skills we use to solve equations, but there's one exception. If you multiply or divide by a negative number, reverse the inequality symbol to keep the statement true. Okay? So if I have, for example, 2 is greater than negative 4. True, right? If I multiply that by a negative 2, 2 is bigger than negative 4, right? 2 times negative 2 becomes negative 4. Negative 4 is bigger than negative 4 times negative 2 becomes negative times a negative becomes a positive 8, right? Negative 4 is greater than 8. no longer true. False. Right? But x is just confusing. That is now false. This was true. 2 is greater than -4, but when I multiplied by a negative, it became false. What you have to do when you multiply by a negative is flip the sign so that it remains true. 2 is less than 3, right? I multiplied both sides by 5. 2 times 5 is 10. 10 is less than 3 times 5 is 15. Still true. Good. 2 is less than 3. Let's multiply by -5. -5 times 2 is a -10, is less than 3 times -5 is a -15. -10 is less than a -15. It isn't, right? -10 is greater than a -15. 20 is less than or equal to 20 is less than or equal to 40. Okay, let's divide them both by a -10. 20 divided by -10 is a -2. -2 is less than or equal to 40 divided by -10 is -4. -2 is less than or equal to -4. That's not true. So anytime you're dividing or multiplying by a negative, flip the sign. That just means if I have to say 2 is less than 3 and I multiply by -5, I also need to flip this sign around. So 3 times a -5 is a -15. 2 times a -5 is a -10, right? That's still true. -10 is bigger than -15 on a number line. Okay. So we're just going to use the same rules you'd use as though this were an equal sign, except if you have to multiply by a negative or divide by a negative to solve. All right. 3x is less than 12. I want x alone, so I'm going to divide by 3. X is less than 4. Good. You can put this into Desmos. So when I put it into Desmos, 3x is less than 12. Looks like this red line with the dot, the red shading with the dot. So it includes all of those answers. If I remove that, x is less than 4 covers the exact same space. So it's a way to check your answer. X divided by -2 is greater than 6. I want to get rid of the denominator, so I'm going to multiply everything by -2 on both sides. Because I'm multiplying by a negative, I'm going to flip that sign, okay? So now I have this canceling, and I have x is less than 6 times -2 is a -12. Good? All right, -5x is less than -10. I'm going to divide by a -5. Divide by a -5. Because I'm dividing by the -5, I need to change the sign. So now the sign, it was facing towards the 5x, now it's going to face towards the -10. -10 times -5 is a +2, and that's just x. X is greater than 2. -x is greater than 7. Okay. How do I get it to be x? Divide by or multiply by -1. -x divided by -1 gives me a positive x. I divided by a -1, so I have to flip the sign. 7 divided by -1 is a -7. So if -x is greater than 7, x is less than -7. Good. All right, and finally down here, it's a bit random, but it is going to be one question on my math lab, so I wanted to cover it. What is the domain of the expression the square root of 6x minus 12? Remember, we talked about domain like the first lesson of this class, but it's okay. What you don't want is we cannot have a negative under the radical as our final radical, okay? So what you do is you take the information under the radical, you take this radicand, 6x minus 12, and you say, I don't care what this is, it can be anything, but it cannot be a negative number, right? What's another way to say it cannot be negative? It has to be greater than or equal to 0, okay? So anytime they're asking you, what is the domain, and you have something like this, what you do is you take everything under the radical and say it's greater than or equal to 0. It cannot be less than 0, right? So now we just solve it. Add 12, solve it for x. Add 12, 6x greater than or equal to 12, divide by 6, divide by 6, x is greater than or equal to 2. What is the domain of the expression? As long as x is 2, that'll be 0. The square root of 0 is 0, so that's fine. If x is bigger than 2, if x is 3, that'll be a positive number, so that's all fine. It just can't be a negative because that would be on the imaginary plane. Good? All right, page 5, example 4. Solve and write your answer using interval notation and graphing. So we have 5 minus 4x is greater than, 5 minus 4x is less than 9. Trying to decide where to write these. Just on a new piece of paper, probably. I like to spread them out because I have to find the answer and then graph the answer. 5 minus 4x is less than 9. Just like we solved the one we just created, we're just going to solve for x. So x is being multiplied by a -4, and then it's being combined with a +5. So I'm just going to move the 5. It's a +5, so I'm going to subtract 5 from both sides. -4x is less than 9 minus 5 is 4. I'm going to divide by a -4 to get x alone. And because I divided by the -4, I have to flip the sign. X is greater than 4 divided by -4 is a -1. Okay, so my answer is x is greater than -1. I'm going to graph it. I like that my variable is on this side, on the left when I'm graphing it. I need a graph of -1. X is greater than -1, or there's an arrow going in that direction, right? There's no equal to, so it's just parentheses. Done, okay? Interval notation for that one would be, I begin at -1 and I go forever in the positive direction. Good? All right, next one was 2x minus 2 is greater than or equal to 3 plus x. Again, we're just solving for x. Here I have a 2x and here I have an x, so I'm going to move this x so that my x remains positive, so I'm not dividing by a negative later, adding more complication. 2x minus x is just x, minus 2, greater than or equal to 3, add the 2, and we have x is greater than or equal to 5. Good? Here's 5. X is greater than, just like the 1. For a -1, it was x is greater than -1, so I know my arrow is going that direction. But it's the equal to that gives it the bracket. No equal to gives it the parentheses, going in that direction. And then when I create interval notation, I just read it. So it's a bracket at 5 going towards infinity. Here we have 4 is less than 2x plus 2, which is less than 10. Now I'm solving for x, but x is in the middle. It's a compound inequality. So anything I do to the 2x plus 2, I also do to the 10 and to the 4. So instead of doing it to both sides of the equation, we do it to all 3 sides of the compound inequality. So subtract 2, subtract 2, subtract 2. 4 minus 2 is 2. 2x, 8. Good. Divide by 2, divide by 2, divide by 2, and I get 1 is less than x is less than 4. Good. So if I look at this one, x is less than 4. And over here I have x is greater than 1. So you're welcome to look at that as x is greater than 1. Good. You're also welcome to split this into two different inequalities. 2x plus 2 is less than 10 will give you x is less than 4. And then 2x plus 2 is greater than 4 will give you x is greater than 1. So for this one, my interval notation is parentheses 1, 4, close the parentheses. Good. Next, one, can't tell where the paper begins. 1 is less than or equal to 2 minus x over 2, which is less than or equal to 4. That's good. All right, so anything I do to the middle, I should do to both the left side and the right side. Here, because 2x is being subtracted from 2, but then divided by 2, I'm going to move this 2 first to get rid of the denominator, okay? They're both being divided by 2, so the better thing to do is to multiply by 2 to get rid of that before doing anything with the 2 or the negative x. So I'm going to multiply everything by 2. And this, of course, in the middle was just to get rid of that denominator. So I'll have 1 times 2 is 2. 2 minus x, because the multiplying by 2 and the dividing by 2 cancel each other out. 4 times 2 is 8. Good. So that's a negative x being combined with a 2, so I'll subtract 2. 2 minus 2 is 0. Negative x, 6. Good. I can't leave it as a negative x. I need to divide by a negative 1 or multiply by a negative 1 and change the signs, right? So if I'm going to divide by negative 1, divide by negative 1, divide by negative 1 to make the x positive, because a negative divided by negative is a positive now, but I need to change that sign. Okay, 6 divided by negative 1 is a negative 6. 0 divided by negative 1 is still 0. Okay, also, I don't like it when my graph goes this way. X is greater than or equal to negative 6. X is less than or equal to 0, because when I go to draw my graph, I'm not going to put 0 here and negative 6 here. I'm going to put negative 6 here and 0 here. So I'm going to flip this all around. Negative 6 is less than or equal to x is less than or equal to 0, so that it's in the order of the number line, okay? So x is greater than or equal to negative 6, and x is less than or equal to 0. So my interval notation will be negative 6 to 0. Good. All right. Our last one was x divided by 17 is greater than or equal to 1 minus x divided by 34. So what should I do here? X divided by 17 is greater than or equal to 1 minus x divided by 34. Well, I should say, can I divide 34 by 17? Oh, I can. Okay, so I need to find, just like when it's an equation, with fractions, you want to find the least common denominator. So the denominators are 34 and 17. If I take 17 and multiply it by 2, it's 34. So 34 is common to both 17 and 34. If I multiply this side and this side by 34, or by 34 over 1, it will get rid of the 17 and the 34 in the denominator, okay? So I'm going to take 34 over 1, and I'm going to multiply it by x over 17, okay? That is greater than or equal to, now I need to take that same 34 times 1, right? And, sorry, 34 times, this 1 should be like the x over 17. And then we have minus 34 over 1 times x over 34. Okay? Now I have on this side 34 times x is a 34x. 17 times 1 is a 17. 34 times 1 is 34 minus 34x divided by 1 over 34. Okay? 34x divided by 17, we know that 34 divided by 17 is 2, so that's actually just 2x. Greater than or equal to 34 minus 34x over 34. 34 divided by 34 is 1, so it's just minus x. Okay? Now my fraction is gone, just solve it like you solve any other inequality. So add x so that all my x's are positive. 2x plus x becomes 3x, greater than or equal to 34 divided by 3 divided by 3. So x is greater than or equal to 34 thirds. All right, and I think that is the end. All right, thank you so much, and see you next time.